So yeah, today I'll be talking a bit about building editor tooling with Fable. As we've discussed before, I've been using F# to JavaScript compilers for quite a while. It's been 3 years, I think, of this long and difficult, sometimes, story. But Fable changes everything. Basically, it makes building JavaScript application in F# possible, easy, and pleasant. So, and yeah, I will be talking a bit about that today. So yeah, my name is Chris. That's this difficult name that Alfonso cannot pronounce. So yeah, let's go further. What do I know about this whole editor tooling thing? 3 years ago, I didn't know anything. Today, I think I know quite a bit. First of all, we've created F# plugin for Atom. That was mainly me, and with a lot of help from Thomas Petryczek and a lot of help from Alfonso with like technical stuff. That quickly evolved into not only F# support, but also into some whole set of plugins to the Atom, which included support for Packet, which is this dependency management tool, and for Fake, which is build system for F#. Yeah, and then time moved forward, and there was Visual Studio Code and blah blah, and we are here with 500,000 downloads on the Visual Studio Code marketplace. So yeah, I will be talking mostly about Visual Studio Code, but Visual Studio Code is only most recent example of this new wave of editors. So starting with Atom, people started to building those editors using Electron. Electron is technology that lets you to run JavaScript UI, graphical UI applications on the desktop. It was created by GitHub. Atom was probably first biggest example of the application using Electron. Right now there are like plenty of those applications of different quality. On the one hand we have Slack, on the other hand we have Visual Studio Code, and there's plenty of room in between. So yeah, first was Atom. I will be talking today mostly about Visual Studio Code, but just for the sake of like putting something in the talk so I don't finish too early. Few informations about Atom. Atom was super interesting, mostly because the model was totally different than any other editor before, at least any other editor I know. Most editors, most IDEs have some kind of extension system that you can write your own plugins for them, and that's fine. What's interesting about Atom is that every core editor functionality was extension on its own. So everything was created using extension API, starting from things like, I don't know, settings view. Default settings view in Atom was extension, and you could turn it off. The about view, which was if you go help about, and there's pop-up saying, oh, this is like Atom version blah blah, created by GitHub. Cool. This is extension to the Atom. This is really interesting because it shows you some kind of philosophy behind the Atom. It shows that the main idea, main thing driving forward people creating Atom was extensibility, was this, how did they call it on the webpage, the most hackable editor in 21st century, something like that, some like super cool sentence, which is true to the point. Unfortunately, this approach has a couple of problems. First of all, the plugins has unlimited access to the editor, which one may argue that it's a good thing and lets people create really cool stuff. Even we abused this feature by creating F# interactive displaying graphs and stuff like that. I'm not sure if you've seen this, but I can find later the pictures of that. On the other hand, the problem is that because people can do crazy stuff, people are not responsible. People are evil, or maybe not evil, people are good, but people want to have fun and people do crazy stuff, which made Atom a bit weird at some points. Have you ever seen power mode plugin to the Atom editor, which basically on every keystroke you do, the whole editor like moves up and down? Yeah, that sounds fun, but oh yeah, but that's like super hacky version that's not really working on the main UI thread like the Atom version. The problem with all this power that this access to everything has, it made Atom has performance problems because all extensions can change everything. All extensions are run inside the Atom. In case of Visual Studio Code, extensions are run in separate processes and stuff like that. So for example, in Atom, one badly working extension can crash whole editor. In case of Visual Studio Code, you will just crash your own process of extension, and nothing will happen with your editing experience. So yeah, also Atom had some problems with design, at least in my point of view of the extension system. For example, all plugins were loaded on the startup of editor, which sounds fun good in theory, but when you start adding plugins for different languages, especially big plugins like Ionide, like TypeScript support in Atom, which is really huge plugin, and all those plugins needs to be loaded on the startup, it makes Atom really slow. On the other hand, we have Visual Studio Code, which is also Electron-based application. It's the application created by Microsoft. It's cross-platform, it's just like Atom. It's fast, it's performant, it has really nice user experience. But that's like, from my point of view, it's not so important. It has completely different extension API. So Visual Studio Code extension API is really high level. You don't have direct access to editor. You don't have access to low level things. Basically, you have set of APIs of interfaces that you can use, and implementing language features, for example, is implementing those interfaces, and Visual Studio Code team cares about this one common user interface and one common user experience that you get for every language that has plugin in Visual Studio Code, which is really good from my point of view as a developer of language extension, because like in Atom, for example, there is no something like tooltip by default in Atom. Tooltips we had in Ionide in Atom version were created by us inside of our extension using jQuery and appending divs to the DOM and setting the content, which is, as you can imagine, not really the thing I want to focus on as a developer of such language extension. I don't really need to care about, I don't want to care about if the pop-up is displayed correctly. I want to care about what's inside the pop-up. Yeah, and the third interesting thing is Monaco. Monaco actually is the editor part of the Visual Studio Code. So basically like this place where you type code without like all panels and stuff like that. That's the Monaco. Monaco is able to run in the browser, as Alfonso showed. In the morning, in the keynotes, it can run in the browser. It was used in Visual Studio Online, something, I don't know, Microsoft stack so well. But it's really cool. It can be also extended. You can add different languages to it. For a while, we had the project called Ionide-web. Well, it still exists and just no one is using it, which basically adds the support for F# to the Monaco, and you can host your own editor in the web page. Oh yeah, and there was one more editor called Lighttable. Anyone remember Lighttable? That was like closure thingy. They started with something else, then they moved to Electron as everyone else. I'm not really sure what's going on with that at the moment. I think for a while Enrico was working on the F# support for that, but Yeah, Visual Studio Code is just good. Yes, and now let's move just to Visual Studio Code. As I've mentioned, extension API is really high level. You cannot do crazy stuff. You don't have access to low level primitives. Yes, and just quickly go through, I will quickly go through this extension API. There are like, this is not formal division of this extension API, but there are like 4 categories of the APIs that you can use. First one are editor features, and that's like obviously like my name, so it's not super correct, but this is things like printing out to the output panel, showing the information message, this like interface user experience related APIs that let you communicate with user and show what's going on, like progress bar, things like that. Second type of the APIs are language features. Oh, and using those APIs is basically like calling the function. These functions usually returns promise, so they are asynchronous in a way. Yeah, and that's all. That's simple. Second, more interesting part of the API are language features. And by language features, I mean the thing that needs to happen if user wants to see the IntelliSense, so autocomplete, or tooltips, or go to definition. Implementing such features is basically implementing interfaces. So you basically care only about behavior that you need to implement, and then Visual Studio Code automatically like pick up. You register that you've implemented provider with given interface, and then Visual Studio Code automatically uses this without any actions from you as a developer. Third part is Debugger. You probably know Visual Studio Code has built-in Debugger for JavaScript and for TypeScript. It can be also used with Fable with the source maps. But also Visual Studio Code lets extension developers create their own debuggers, which is again something super cool because I don't really know any other IDE or editor when you can so easily create debugger extension. Well, in some of them there is no any interface for that, like in Atom or in Vim, and in other like Visual Studio it's super difficult. So we have debugger. And fourth kind, which was added recently, is version control system API. So initially the Visual Studio Code was using only Git, and Git was built in as a core feature of the editor. But at some point, like 3 months ago, I think, or 4 months ago, they've created also API for version control system, and they moved Git support to extension, which is shipped together with the editor, but at least it shows that you can create extensions adding new version control system. And I believe there is molecular support on the marketplace. I'm not sure if there is anything else but that, but if you would like to create support for TFS, then yeah, it's possible. Yes, and now, how much time do I have? Yeah, great. And now I will quickly go through some features of both F# and Fable that I think like enables me pretty implement features in Ionide, in Visual Studio Code extensions pretty easily, and why this whole thing is working well together. So first of all, it's not really specific to F# or to Fable. It's rather this typical functional programming thing when functional programming is great for pipelining data and data manipulation in a step-by-step manner. So really a lot of features in Ionide look like this. So you get editor data, maybe not from unit, but from current position of the cursor or currently opened editor, opened file. You transform this data from the editor format to server format. You serialize it, you send a request to server, you get response from the server, you deserialize it, transform again, and send to API. So that's like simple pipeline. We probably all have written such code somewhere. Yeah, and as you know, that's great fit for functional programming in general. Second thing is async programming. Visual Studio Code API is, well, let's start. As you know, Fable supports both normal F# async, but also JavaScript promises. JavaScript promises are kind of similar to asyncs, whatever, we won't go into technical details of that. Basically, they both let you do the same thing, so do some asynchronous operations. And whole, basically 100% of Visual Studio Code APIs, ignoring single properties that can just be like, let's get the name of something. Anything else is using promise-based APIs. So every call to the function, show the information, or show quick picker, or show text box, returns promise, which is resolved when user do something, do interaction. Fable supports computation expressions. Computation expressions are those like magic blocks of code, of F# code, that can have override like behavior that happens on the let. So you have this let bank thing. You probably know that from the async, maybe from the seek, which are built in F#, but you can also create your own computation expressions. And we in Ionide have created promise computation expression. It's also in Fable Power Pack nowadays. Yes. But back in the days when we've started, there was no promise, there was no Fable Power Pack. So we've created, like Dave Thomas created the promise computation expression, and that's the one we are still using. We need to switch to the official one. Maybe I will show some code at this point of time. I was really like, I didn't know how to prepare samples for this talk. So I've decided that I won't prepare samples. Instead, I will go to Visual Studio Code, and I have Ionide open. And let's try to find promise. Okay, here we are. So yeah, we have this promise block, promise computation expression, inside of which we have in one place, well, that's just the in this particular function, but in other we have many more promises we bind together. We have let bank, we have this window show input box function, which basically displays what? Sorry? Oh, sorry. Yes, obviously. Thank you for reminder. How do you zoom that in Visual Studio Code? Is that a bit better? Thank you. What was? Yeah, so there's promise computation expression, there's let bank, show input box returns promise of string. This string is the string that user has inputted in the input box, and when the action is resolved, we do something after this promise has been resolved. And as a result, as you can see, we return the promise. Oh, by the way, this is like so cool. This new feature in Ionide, thanks to VBFox. What is VBFox? Yay! So you probably know that Visual Studio Code and Ionide had this feature called code lenses, which like display the function signatures above the function. The problem with that was sometimes if you had not so good PC or you have really big files and stuff like that, the F# compiler services performance was not good enough, or like we have done some crazy stuff and that was too slow. So it caused the code to jump because code lenses disappeared and were appearing again. There's no problem with that. There's a new thing called line lenses. So we basically put line lenses, this function signature virtually here next to the function instead on top of that, on top of the function. Thanks to that, even if this function, this signature disappears because compiler services are calculating or waiting, it won't cause code to move because it's not changing vertical alignment of the code. So yeah, that's amazing, especially for like docs, because when I would start writing something, it would look silly when the code would jump, and that would not be good marketing. So with that, and also you can do like nice colors, as you can see, for those code lenses. Oh yeah, by default there is some sign color. That's like this pink is, I've chosen it to test the coloring because I've merged the pull request before the launch. So yeah, so that's promises. Promises are used everywhere in Ionide's code base. If you try to, maybe we'll try to find all usages. So yeah, there's like everywhere in every file multiple times. 73 references of promise computation expression. And we don't use promise computation expression everywhere. We sometimes use just combinators like promise.bind and promise.map and promise.iter. So promises are used everywhere. And Fable works great with computation expressions, so we are happy. Happy panda. Second thing is general language expressiveness. As you know, F# is expressive language. F# has things like records and discriminated unions. F# has things like pattern matching. F# has things like active patterns. And all those things are maybe not crucial, maybe not critical for us, but at least let us model our domain way better and help us in general, like code structure, and ensure that we don't do anything stupid. Well, we do stupid things pretty often, but that's not the fault of the F#. That's just me. So yeah, for example, in Ionide version 3.0 that was released like 9 days ago or 10 days ago, we've added Solution Explorer. Well, actually, Solution Explorer was added before that, but in recent version, we've added support for solution files. And that's the model of the tree view that we have here. Of this tree view that has different types of nodes and so on and so on. Oh, by the way, the pull request that added the icons to the Project Explorer is super hacky, and it's also by VBFox. Because like Visual Studio Code API doesn't actually let you define those icons on the runtime. You can only, well, you can define them on runtime, but you don't have access to currently chosen icon theme, because in Visual Studio Code you can choose icon theme, which changes the icons in this normal file explorer. Unfortunately, there is no way of getting icon for given file from actually currently working icon theme. So there is some magic going on here that I don't understand at all, and we get icons here. Yeah, so again, the discriminated union, the record type, and that's all what was necessary to model the project system in Visual Studio Code. Apparently, project system is super difficult part of the editor, like Visual Studio. Not working project system shows us, but yeah, whatever. What else I was talking about? I was talking about also about active patterns. Active patterns are super cool feature of F#. I'm not sure if many of you heard about it or using it, but basically you can define custom match cases based on some logic which is hidden under the hood. So for example, here we match on the document which we get, and if this document has type F#, then we do something. If it has other type, we do nothing. And if we go to the body of this thingy, as you can see, that's like some logic, some ifs, but that's written once and it's hidden, and you don't ever need to care about that. And in all other places, you can do normal match statement, and you have this nice readable code that express your domain and what you want to do, instead of focusing on control flow and focusing on some simple if statements. Yeah, so that's cool. Next thing is OO interrupt. As you probably know, F# has really decent interrupt with object-oriented programming, maybe with object programming, depending on your definition. You can do classes, you can do interfaces, you can do abstract classes, whatever. This is super important for us because TypeScript is written in, well, because Visual Studio Code is written in TypeScript. TypeScript is object-oriented language. Visual Studio Code is designed by a guy named Erich Gamma. You can probably know him from this Gang of Four book of design patterns. So you probably can imagine that he's pretty likes OO. So the whole API is a bit like OO API. So you need to implement interfaces, for example. So it's really important for us that we can have this OO interrupt because, yeah, that's basically what lets us use this API without any problems. Actually, I think that some feature of F# is letting us use this API in much nicer way than usual TypeScript or other OO languages. It's implementing interfaces, and by implementing interfaces, I don't mean actually implementing interfaces on the classes. I mean something called object expressions, which lets you implement interface like inline instead of creating full type and implementing this interface, overloading all members and blah blah. Let's find that. Create provider. Okay, so here it is. This is the implementation of interface. So there is this is name of interface, which has one method to implement with. We provide the method and we close, and that's implemented inline without creating any additional type, without like putting this type somewhere in the code base and worrying if like dependencies are okay. This is basically just a single function that returns the instance of this interface implemented inline. So that's cool. We love that. That's one of my favorite features of F# in general. When you interrupt with OO code bases, I think it's underused. So learn it, love it, and use it. Oh yeah, and it obviously works super well in Fable, as everything. That's actually boring talk because like everything works well in Fable. So talks about, whoops, that's not what I wanted to show. But functional programming Slack is a really cool place. You should join. There is fpslack.com, and there is super active F# channel, and also there is official F# org Slack channel, which is less cool, but there is a lot of people there. It's less trolly. That's what I mean by less cool. Another really important thing for us is Node.js interrupt, because Visual Studio Code is Electron application. Visual Studio Code is using Node.js. Visual Studio Code has access to all Node.js APIs that we have, like child process or file system or path, etc. So Node.js interrupt is super important for us in two cases. First of all, we have access to Node.js standard library, so we can spawn external process. We can check if file exists on the disk and stuff like that. And the other thing is using external dependencies that we can find on NPM, which we don't use so much, but there are a couple of places where we use external dependencies. For example, for doing HTTP requests in more promise-based, with more promise-based API, we do some external dependency for parsing some files. Yeah, that would be it. Yeah, and maybe again, let's try to show some code. No, Slack, turn off yourself, please. Not today. Okay, so there is the normal fsharp function. Yeah, it's doing some things that's not really important. First of all, it's using the promise.create, which is Fable ways of using, and I guess JS way of using promises or creating promises. The second thing is this child process.exa, and that's called from using Node.js. So we are calling normal Node.js API here. As you can see, it's like Fable import node something else. So that's super important. And the second thing is we also use external dependencies. And what's important for me personally in using external dependencies is that it's super easy to create function using external dependency, because there is this emit attribute that you can just use to create the API for like bindings for the external dependency without a lot of effort. So that's basically creating signature of the function and then telling the Fable how it should behave, what should it emit when this function is called. Yes, I shouldn't do this way, but I'm lazy, and that's the why I shouldn't do this way. What should I do instead? I know JavaScript. I know JavaScript, man. I can import. I can write correct JavaScript inside. Yeah, so I should do this like that, right? So that's the bindings that generated by TS2 Fable utility exactly. So yeah, that's basically file with a lot of errors, a lot of warnings, but that doesn't matter. It's how many lines of code is it? It's 700 lines of code of APIs definitions for Visual Studio Code, and you have type access to all function calls, all APIs that you need to use. And this was automatically generated by TS2 Fable, which is the utility that lets you transform TypeScript definition files into Fable binding files, which works pretty okay. It has some problems. Sometimes you need to fix the generated file manually, but in general I'm pretty happy with that. I would be even more happy if it supported comments, but yeah. On it. Okay. So tomorrow. Love you. Yeah, fast feedback loop. That's not really. That's partially connected with Fable. That's partially connected with how Visual Studio Code works. So Fable lets you do watch mode. So running Fable in the background, and whenever you save the file, it automatically recompiles stuff. That works really great with Visual Studio Code. Basically, you fire experimental instance of the Visual Studio Code that targets the directory with your extension that you develop. You edit it in another instance of Visual Studio Code, and whenever you save file, it's automatically recompiled. You just reload, do Windows reload command in experimental instance, and you get new version of the code loaded in experimental instance. That's super important. That makes my life much easier and life all contributors much easier. If you come to my workshop tomorrow, that I will show in more details how it works. Oh yeah, and that's what I was talking about. Fable Watch plus editor reloading. So that's cool. And last, how much time do I have? 2:15. Okay, so I should end, but give me like 2 more minutes and then I will have cool announcements. So please stay with me. Community aspect is super important for us because who is interested in doing F# tooling? Obviously, F# developers are interested in F# tooling. So it would be nice to have F# developers that want to contribute to F# tooling be able to use F# for that, because that's what they want to use. So using Fable is really, really important from this point of view. Other thing, I really love Fable, and I loved it from the first version, from the first view. So it was really important to me to like fastly move to Fable to just show that this project has future. So if like I was really like I've recently checked and I've started using Fable on version 0.1.11 or 0.10, which was super early alpha and was terrible, but showed some promise. And even in this super early version, we were able to create the working version of Ionide and deploy it. And some of you maybe has used the versions of Ionide created with those super early versions. So that was also really important to me to commit to the supporting of the Fable. Maybe not directly as a contributor, not so much at least, but as showing that the project has future. Ask me anything. If you have any questions, I have the workshop tomorrow about these things. We will on the workshop we will create working Visual Studio Code extension, and we will play with some APIs. So yeah, this will be fun. I hope that it will work, but yeah, I need to create some samples. But yeah, I have a lot of time for that. So yeah. My name is Chris again. You can find me on Twitter, you can find me on GitHub, you can find me on Instagram and 500px if you are more interested in photography than in programming. My blog post, F# Today, is the webpage I've created with all fancy, cool community projects that I like and that I think are super important for F# ecosystem in general. Fable obviously is one of the examples there. Lambda Factory is my company. And speaking of my company, that's the end of the first of the boring part, so the talk. And now going to announcements. How do you quit? Oh yeah, computers are difficult. What's the web page? So today, my company Lambda Factory, together with Compositional IT, which is the company of Isaac Abraham, founded by Isaac Abraham, we decided to create this thing called Safe. Safe is yeah, as it's written on the web page. It's end-to-end functional first stack for cloud-ready web development that emphasizes type safety. That's really fancy way of saying it. Basically, what we want to do is to create technology stack based on some projects from the community, put them together, show how you can use them together, show samples, show all the things you can do with them. And also what's important is that both my company and Isaac's company provides commercial support for this stack. So if you don't know how to start, if you want to start and you look people to help you, there are two commercial choices: to go and to seek help consulting. Yes, and the stack contains Swap on the server, which is this super nice F# idiomatic web server that can run cross-platform. It contains Azure as a cloud platform. It contains obviously Fable, that's why I'm announcing it here, as a way to writing JavaScript application, and it contains Elmish as a best way of writing UI in the Fable, at least according to us. And what's important is that those are technologies we suggest. Those are technologies we think that are best, but we also show some kind of alternatives for different parts of this stack. So for the server, you can use something else like Giraffe, Freya, WebSharper, which is a great product. maybe plain ASP.NET if you like pain. Then on the cloud platform, you can use AWS, you can use Google Cloud Platform, you can even use Webtask.io to do some like hosting serverless things. On client side, there is Fable, obviously. There is also WebSharper. You can just write JavaScript if you like pain again. You can use Elm, whatever. And UI rendering, Elmish, and Elmish once again. No, seriously, there is also like you can just do something else. So yeah, please visit the site. As I've mentioned, there are 2 companies right now that we decided to provide commercial support for that, and we decided to be really committed to that. Obviously, the whole stack is based on the open source libraries, so if you seek help for one of those projects, the community will help you with that. So yeah, so that would be it. That would be announcement. I'm here, so you can talk with me about that. There is Twitter, @safe_stack. You can find us, like me, and people from compositional IT on the Slack channels, on the Gitters, on the Twitter. So you know who we are in general. Okay, and that would be it for today. And thank you. So any questions regarding anything? Ask me anything. Photography, traveling. What's the reason for the universe? Should you get the mic? Alfonso is like tweeting or doing something else, so he's too busy to. That's the question. You should pay attention. You are organizer. You are organizer. You should pay attention to what's going on.
Well, the organization team is not that great. I'm sorry.
Yeah, I understand that. No problem.
Okay, thank you very much. So the answer to the life and universe?
F#.
Okay.
And safe. And safe stack.
And safe. Okay, thank you.
Perfect. Okay, so if there's no more questions, then thank you. Oh, yeah, there's a question.
I already asked Isaac and Stefan this, but wondering about a simpler database story in the safe stack rather than sort of Azure, which is sort of fine, but what about MySQL or something?
Yes,
it looks to me that a lot of people will come to F# expecting it to have a very simple stack, much like Safe, just with MySQL as replacing Azure.
Yes, as I've mentioned before, it's not all or nothing stack. All parts can be changed. All parts can be easily changed for something else. And if you go to the compositional IT blog post announcement about Safe Stack, there is like a couple of different alternatives that you can use. So yeah, there's like AWS, whatever, but there's also on-premise web stack when you just host your stuff on your local machines with MySQL or Postgres or whatever you want. Yeah. Again, also you can host those databases in Azure. Nothing stops you from that. So it's not like we are committed to one.
Yeah, I understand. I'm more wondering whether there's an opportunity here for you to be the go-to stack for people looking for F#.
Yes, that's
MySQL and with the support option as well.
Yes, that's basically our hope. We believe, like both me, Isaac, Stefan is super excited about the project. Alfonso helped us a bit. So it's not only like our companies, we also have this community support, and in general, we believe that F# was lacking this one go-to place saying how you should develop web application in F# because there's so many options and so many alternatives. And for new people, like I'm doing consulting, I'm doing training, so I talk often with people new to F# or I try to introduce F# to the organizations. And I often say that it's confusing for the people that there are so many options, so many choices, and you can mix them completely. So we try to create this one at least somehow more robust or more user-friendly way of putting everything together. But again, if you want to mix it with something else, we are also happy to do that. So yeah, that would be answer, I guess.
Yeah. Oh, you probably get a lot of that. Like, how many variations are you going to be considering for support and for training? Yeah, but anyway, that's something you'll have to consider.
That's probably like a bit individual with the I cannot speak what Isaac's company want to do.
Yeah,
and,
between everyone involved in the stack.
I think we are like the most important is this default path for us. Then supporting some other idiomatic F# choices. So the Giraffe, maybe Freya.
Yeah.
In terms of the platform stack, I don't really think that matters so much, to be fair.
I think what matters is that people coming from other ecosystems looking to adopt F# and looking for its stack.
Yeah, and they don't want to do only Azure, for example.
They will expect MySQL to be a database option in the stack they're coming to, and they might walk away from it.
Yes, that will be definitely like
option.
we just
you just got millions of people coming. Tens of thousands, hundreds of thousands coming to look at this and making that decision based on that perspective. Is it what they expect it to be? And when then they see it's different with Azure, I know MySQL highlighted, they'll just walk away. So anyway, just
that's a good point. That's a really good point.
I'm trying to maximize your business here, Krzysztof.
Thank you. We've just started. I've put this webpage yesterday in the 3 AM. So it will definitely like be we are just starting. We hope that other companies may join us. It's not like we are fighting with anyone. It's not like we want to take anyone's jobs. We hope that if you are a consulting company doing F#, you will like our idea and join us, and we will be able to provide this nice story for F# developers and for new users joining our stack. Yeah, and okay. Meaning of life?
So I'm actually just curious about the recommendation for the stack about deployment. Are you recommending deploying to Windows? Programming on Windows, deploying to Linux? Programming on Linux and deploying to Linux?
Programming on anything you want.
Okay.
Because we have Ionide and it works great cross-platform, because we have Visual Studio for Mac, because we have Rider, and on Windows obviously we have Visual Studio. In case of deployment, I think that the thing both me and Isaac's company have most experience is deploying to Azure Web Services and web apps. So that's like on Windows, but you really doesn't manage the infrastructure so much. I personally deploy to Azure Functions, which is like serverless, and I do like REST APIs on the hosting on serverless. And I guess like with .NET Core, nothing stops you from deploying to Linux.
Except type providers?
Oh yeah, except type providers.
Right, so accessing data.
Well, you can access data still. Normally, there are plenty of options in .NET Stack in general to access the data without type providers. Many people use them. So, and hopefully, type providers will come to the .NET Core sooner or later. Yeah. Yes. Yeah, so it's definitely not possible, but like let's be fair, like handling .NET Core problems with compiler is not our pay grade. We try to focus on things we can do, I guess.
Just my curiosity, I don't know Fable besides using it, sort of what's inside. I'm not Fable, Ionide. So is it majorly just like providing like this type hinting and all the stuff that you do? Is this just like extension of the compiler services,
Ye-
or are you actually doing like the analysis of stuff?
Okay, so F# compiler there is project called F# compiler services, which is basically F# compiler with some additional APIs and some public APIs that are normally private in the compiler. That's basically fork of the compiler. This project is used by, I think, most of the F# tools, like editor tooling. So it's used by Visual Studio for Mac. It's used by Rider support. It's used by tools like Phantomas for code formatting, or F#lint for the additional linting rules. On top of that, there is a project called FS Autocomplete, which is the application that wraps that's wrapper around F# compiler services, that's letting users communicate with F# compiler services using standard input-output or HTTP protocols. Just because, well, if you do extension for Vim or for Emacs or even for Visual Studio Code, those are not .NET language runtime programs, applications, so you cannot just directly call .NET library, which is F# compiler services, normal .NET library. So we have this wrapper, this communication layer. Huge bunch of logic is inside FS Autocomplete, because like F# compiler services are a bit low level, I would call it that. And in FS Autocomplete we implement a bunch of higher level functions. So just like you are at this position, what are like completions, or you are at this position, and what is tooltip. So we are using that. And then on the Ionide side, we basically, for the language features, so for the features based on an F# compiler, we call this FS Autocomplete things. So all tooltips, IntelliSense, rename, go to definition, code lenses, all those things that are directly related to the language and to correctness, like error highlighting, are using FS Autocomplete. FS Autocomplete also has built-in F#lint support, so that's another thing we are using through FS Autocomplete. But Ionide provides many more features, like Solution Explorer, for example, which displays the files in your solution, order it like you need in F# and things like that. You can create new projects and things like that. And for that, we integrate with some different tools, command line tools that are created by sometimes me, sometimes someone else. So for project manipulation and project scaffolding and project creation, we communicate with a tool called Forge, which is like I've written something and put it somewhere on GitHub and people like it. We communicate with Packet for the dependency management. We communicate with Fake. We communicate with with normal plain MS build for building. That will be it. So yeah, that's basically the general architecture.
Also, do you maintain any contact with people doing the similar work on the actual Visual Studio, not the code version?
Yeah, I know Don.
Oh,
okay. No, like the visual F# tools are open source projects, so and it's like really good open source project. So the whole work is done in the public, in the open. So you can always discuss things on the visual F# repository. You can ask people for help. You can ask Don for help. You can ask Kevin, who is one of the main developers on the Visual F# team, for help. You can ask Philip, who is project manager, for help. Yeah, I like keep in touch with them. Yeah, and I don't think it's a problem. Like it's not like that I'm super like special because I've written something, and that's why those people talk with me. But anyone who wants to use F# compiler services, if you have any problems, just create issue, and I'm pretty sure people will be happy to help. Either people doing F# compiler services or people who are using it to have more experience with that.